So I hope everyone had a nice and relaxing break. I just want to start off with the calendar again and see if you guys have any questions for these remaining weeks. So we're condensing our trig unit to just three big topics here. Three main topics: trig derivatives, which we started the Friday before break, and we're going to do review of that. So I have that worksheet that I included in the link in that remind message I sent yesterday. So hopefully you guys all have that. If not, you just follow along with the problems that we're going to do. Tomorrow we'll do trig related rates. We'll probably spend 2 days on that. 1 day to introduce it, another day to get some practice with it. Thursday we'll do inverse trig. This is our last new topic. And then we'll have Friday and Monday to do quiz review. Just our trig unit just going to be these three topics. We'll have our quiz on Tuesday. This will be the final required grade in the grade book. Still looking to see when we can do a test recovery for that chapter 5 test. But right now I'm thinking about that Wednesday to be that recovery test date. We'll spend a couple days reviewing for our final exam. But the final exam is it's going to be optional, meaning that you don't have to take it. But if you do take it, it can only help your grade. So if you do, if it helps your grade, I'll enter it in the grade book. Or I can also use it to replace your lowest test grade. So what may happen is if it helps your test grade, then I'll put it in the grade book. It'll be 15% of your grade. Uh, 15% of your grade, and then I can also let it replace your lowest test grade or quiz grade, depending on which one is helpful. Right? Or maybe there's a scenario where it's not beneficial to put it in the grade book, but it's beneficial to replace your lowest test grade. If that's the case, I can do that as well. So I'll go through a couple of different scenarios once you've taken your final exam to see which option will help your grade the most. Okay. All right, so this is what the final 3 weeks look like. Any questions that you guys have?
So for the final exam, is that the case for all of our classes? Like if it doesn't benefit our grade, like it doesn't go in? Or is that just for...
That should be the case. That should be the case. Well, I know that for math department, we our department had well, we made the decision that we're going to have 8 grades, and that 9th grade in the grade book is going to be optional. So, you know what? I don't know. I don't know if all of your other classes are making their final exam optional, but I know that for us, we only are. Well, the Fulton County says 80% of your students have to complete 80% of their of the grades in the grade book in order to be sufficient. So our 80% is 8 out of the 9 grades. So that 9th, this is the 9th grade in the grade book, which is outside of that 80%. So that's why we're making it optional. But yeah, I think all the classes are only requiring 80% of the grades to be required for students to in the grade book, right? So I think so. I think all the classes should are probably doing what we're doing here. But I think that's a department decision based off of the different departments. Okay, any other questions?
Just making sure the quiz next Tuesday is going to be a summative, right?
Yeah, summative. Yes, summative.
Okay.
Right. Yeah. Yeah, this will go in the grade book.
And is everything like that we've already done, that is due this Friday, right? Is that what I've heard?
What do you mean?
I heard the past classes have said that this Friday all the grades are due.
Yes, all the grades are due on Friday, but Principal Jones also sent out an email saying that if teachers, up to teacher discretion, can add or change grades that come after it. So
Okay, that's fine.
I guess technically, if I have to submit grades, I'll submit grades, and maybe I'll just put a dummy grade in for this trig derivative quiz, and then I'll go back and I'll change it when we get to this. But yeah,
Okay.
I think teachers have the flexibility to, as long as we make it known ahead of time, teachers have the flexibility to add or change grades after grades are due.
Okay, thank you.
Yeah. Okay, so this is what we did on that Friday before break. We focused on these derivative rules. But with these derivative rules, the challenging part of trig function is really the chain rule. And so we spent time just practicing rewriting our problem using brackets so that we can visually see there's a third layer involved with trig functions, and being able to spot that or being able to identify that is the important part. If we can identify it, then you have a much better chance of being able to create the appropriate derivative of our problem. So for instance, if I see a square root involved with a trig function, I'm going to rewrite it as bracket to the 1/2. Here, this is cube root. I'm going to rewrite it as bracket to the 1/3. And here, this squared here is a shorthand form of representing the entire function as being squared. So I'm going to rewrite it in a visually more helpful manner and put it as bracket squared. So once we can get all these brackets to show up, then we can see kind of the different parts of the problem. You got the bracket to the 1/2 being the outside portion. You got the cosine parentheses as the inside, and then you have the x squared being the inner portion, or the innermost portion. And with chain rule, we're just going to take turns with each of these derivatives, and they're all going to take up a different space of our derivative. So bracket to the 1/2 becomes 1/2 bracket to the negative 1/2, right? We're just doing power rule, pretending like the bracket is its own variable. And then we're going to fill the bracket in with the original portion. Next up is cosine's derivative. Cosine becomes negative sine of u, of the whatever's inside the original. And then finally, the innermost portion, x squared, becomes 2x. So once you can identify the outside, inside, inner, then everything just becomes very methodical, right? You're just taking turns with each derivative, and you're placing them in a different location. A common mistake that students make is they would take each of these derivatives, but then they would insert them all into the same space. Okay, we don't want to do that. It looks a little cleaner, but it's not the right way to do it, right? We have to put all the derivatives in its own space, not inside one another. Okay, same thing here. Outside's derivative, inside's derivative, inner portion's derivative. For example 6, we have multiple y's in the equation, so I can find the derivative involving dy dx. Sine of u becomes cosine of u times u prime, and u prime is where we have to activate the derivative of each of these terms inside. So x becomes 1, y becomes dy dx. From here, we can distribute the cosine through, get the dy dx terms separated and moved around. So we can factor that dy dx out and then divide over. Okay, so we're just going to practice with these. So we're going to start off with the trig derivatives worksheet here. All right, so 39. Derivatives are up here for our reference. F of t equals t squared sine of t. What process is involved to find the derivative here that you can see?
With that product rule, maybe?
Yes, good, product rule. All right, so we obviously see a need for power rule. We see a need for sine's derivative, but we also have to recognize that these are two separate terms. They're being multiplied, so we can't just do derivative of these two terms and stop, right? We have to go through that product rule. Okay, so spend a minute, see if you can build the derivative from here. All right, so f prime becomes 2t. The original g function back to f. G prime, so sine of t becomes cosine of t times 1. So that 1 is not going to impact our problem. So we can leave that out if you want. Not much to clean up. I guess you could factor a t out, but you can just, this is sufficient. All right, any questions with 39? All right, 42, what's involved here?
Quotient.
Quotient rule. So I think in general, I think we have an easier time spotting quotient rule, right? Numerator denominator is a lot more obvious. Sometimes product rule is kind of hidden, and we don't remember product rule. So I think even though I think product rule is easier to apply, sometimes it's harder to spot. Right? Quotient rule, maybe it's a little bit more cumbersome, but it's easier to spot. The numerator denominator gives it away. Okay, so let's see if we can find the derivative. Spend a minute to do that. Okay, f prime cosine x times the original g function back to f g prime 3x squared all over denominator squared. I'm going to use the space for 44. We'll skip 44, so I'll just move the problem down here. I can do a little bit of cleanup, and then I can also eventually factor an x squared out. And once I factor x squared out, I can use it to cancel out some of these x's below.
Yeah.
X squared come up.
I have a question.
Yeah.
Do you think after class we could maybe get a house tour?
No. All right. X squared, x is 6. We can cancel these out. X to the 4th. All right, f prime. All right, any questions there? 42. All right, 53 and 54. We won't do these fully, but I just want us to see the steps involved here. So 53, what do you see is involved here, 53?
Some product rule?
Okay, how many times?
Twice.
Yeah, so yeah, I think product rule just tends to be hidden sometimes from students, so I just wanted to make sure we can see that. How about 54?
Twice product rule.
Yeah, theta is just another variable. It's like 5x secant x plus x tangent x. Okay, let's go to the next page and we can practice with chain and implicit. Okay. All right, 43. All right, cosine of 4x. We can, this is a little bit of a chain rule, not a huge one, but enough for us to have something different with the u prime. It's more than just the 1, so I like to have that instead of parentheses as a reminder that I'm staring at my u value that's inside the cosine function. So y prime equals so cosine of u becomes negative sine of u times u prime. So negative sine of u times u prime, which is 4. And that's our derivative here. Okay, questions there? All right, 53. We have y is equal to secant squared x. So this is where rewriting that exponent is going to be helpful for us to see the different parts of chain rule. But here, there's only 2 layers here. There's only an outside and inside. The outside portion being 4 brackets squared. And then the inside portion being the secant x. So we're taking turns with each of these derivatives and placing them next to each other. So 4 brackets squared becomes 8 bracket to the first power. Fill in the bracket with the original term inside. And then we can focus on secant's derivative, which is secant x tangent x times 1. And then we can do a little bit of cleanup by pushing the 2 secants together. Any questions with 53? All right, try 54. 54, we have 3 different parts that we have to identify with chain rule. So see if you can rewrite the problem. And after you rewrite it, see if you can identify the outside portion, the inside portion, and then the inner portion. Okay, spend a minute, try that.
So would the outer be 5 cubed?
Yeah, that's right. 5 bracket cubed. Yeah. Okay, so your rewrite should look like this. I think having the pi x inside its own set of parentheses just makes it a little bit more obvious as to what your inner portion is going to be. Yeah, if you can identify your different parts of chain rule, then it's going to make your derivative a lot easier, right? Being able to spot this is, I think, the most important step. If you can do this, everything else just kind of falls into place, as long as we remember that we're going to take turns with each derivative in their own separate space. Okay, so outside's derivative, 15 bracket squared. Fill in the bracket with the original problem, no changes. So we took care of this. Now we're moving on to cosine's derivative, which is negative sine. Fill in this parentheses with the original. And now moving on to the inner portion's derivative, pi x, we can just do power rule. It's like 3x, right? 3x becomes 3, pi x becomes pi. Clean up, I'm just going to put all the coefficients together. Okay, any questions with 54? All right, let's look at some of these problems below involving implicit. So let's look at 11, 13, and 15. Okay, we know we have to involve implicit if you see y kind of mixed into the equation, is not isolated like previous problems. Okay, yeah, I guess a little bit of chain because we got to involve u prime here. But we're going to jump directly into our derivative rules here. So sine becomes cosine. Cosine becomes negative sine of u times u prime. So I have negative, the 2 just hangs out, it's a coefficient, negative sine of u times u prime. And 2y's derivative is just 2, but we're also involving y's derivative, so we need to include the dy dx. And then the 1 becomes a 0. Okay, any questions here? now we just want to try to get that dy dx by itself. Okay, we divide the 4 sine 2y over. All right, questions here. Okay, let's look at 13. Okay, we know there's implicit because you have y kind of inside the equation here. What else is involved that you can see?
Change.
Yes, there's a little bit of chain with that tangent of y, but there's another big thing here.
It would also be no, never mind.
Would there be product?
Yeah, there's gonna be product rule here. Right, and I think that's just a tendency, right? We have, these are harder to spot because they're kind of hidden in the problem, but the x and the 1 plus tangent y, these are two separate terms. The parentheses kind of helps us see that there's a multiplication going on here. So we got to go through product rule. Okay, so let's jump down with our steps here. Sine becomes cosine. All right, sine becomes cosine. F prime, x becomes 1. Back to f. And then g prime. So we want to take tangent derivative, which is secant squared y times dy dx. There's only one y in our equation, so we're only expecting one dy dx to pop up. So now we can just subtract this over. I'm sorry, g is 1 plus tangent y, right? Sorry, I left out that 1 plus in here. Okay, we'll subtract this over and then divide that x secant squared y. We can isolate that dy dx. All right, questions here, 13? Okay, 15. Y equals sine xy. There's quite a bit involved here, so let's see if we can identify those things. Okay. 3 things I want us to identify. What do you see?
Product rule.
Okay, product rule with that x times y, right?
Implicit.
Yeah, there's multiple y's. There's one more here.
Chain.
Yeah, chain rule, because my u value is more than just an x. So anytime my u value is more than x, there's always going to be a u prime that's going to be more than just a 1, right? So between chain rule and product rule, which one is going to get applied first?
Product.
So here's the thing, is that we want to see which affects a larger portion of the problem. Does chain affect a larger portion or product over? Right. We look at the parentheses, right? If the parentheses is over only a portion of the problem, well, I guess, I'm sorry. I guess this is kind of backwards here. But here we see that product rule is only impacting the xy, but chain rule is the sine of u times u prime. So there's, it's going to affect a larger portion of the problem, right? So, yeah. So we're not going to get to this product rule until we're inside the chain rule. That u prime is where we're going to activate that xy's derivative. So sine's derivative is going to be, this is my u value, right? Sine of u becomes cosine of u times u prime. And when we get to u prime is where that xy is going to have to involve product rule. All right, so I want to just help you see the progression that we're applying to get to eventually what we need. Okay, so let's start from the beginning here. Y becomes 1 dy dx. So whenever I'm doing implicit and I just only see a y by itself, I like to put a 1 in front of it so that eventually when I factor dy dx out, as I have a visual reminder that there's a placeholder, there's something that's going to still be there in place of that term, even though dy dx gets factored out. Okay, so sine of xy becomes cosine of xy. Times u prime, and u prime is where we have to find the derivative of xy, and xy is they're related to one another by multiplication, so I got to go through product rule here. F prime g plus fg prime. X becomes 1. G function is the y. Back to f. And then g prime, y's derivative is 1 dy dx. Right, so a lot of things packed into one step here. But this is the only calculus step we have in the problem. The rest is just trying to clean up, get that dy dx by itself. Okay. Any questions here? All right, so we want to isolate the dy dx, but right now the dy dx is kind of stuck inside the parentheses with the cosine xy outside of it. So I'm going to distribute the cosine xy through, and that will help me separate these terms, and I'm going to have an easier time moving these terms around to get dy dx. So when I distribute the cosine xy through, I'll get y cosine xy plus x cosine xy times dy dx. Now that I have my terms kind of separated, kind of independent from each other, I can start moving some terms around. I'm going to have these two terms on the same side, so I can factor dy dx out. Subtract the x cosine xy over to the left side. Factor dy dx out. I'm left with 1 minus x cosine xy. So I think having that 1 is helpful, right? If we factor dy dx out, we remember there's still a 1 left over. And then final step, divide the parentheses over. This is as far as we can go. Maybe some of you are looking to try to cancel these x cosine xy out, but this is attached to the a 1 with a minus in between, so we can't cancel across addition or subtraction. Now, if there's only a negative x cosine xy, then yes, then these are fair to cancel out. But this kind of restricts what we can do. Okay, any questions? Okay, so tomorrow we're going to start related rates for Trig. Spend tomorrow and Wednesday. Wednesday we'll spend as a review day going over just getting some additional problems under our belt, get some practice in. So, those worksheets are available and ready on my website under tomorrow and Wednesday's date. So feel free to print those out. Okay. All right, that's all I have. Hope you guys have a great day. I'll see you guys tomorrow.
Thank you, Mr. Yang.
See you
Thank
guys.
you.
Bye.
Thank you.
Have a great day, guys.
Mr. Yang,
Yes.
I'm not sure if you'll know the answer to this, but I had emailed my counselor a while ago asking if I'd be able to double up on math next year, and she never answered me. So do you know if we're allowed to do that?
You mean like BC and stats?
Yes.
Yes. Yeah, you can do that.
Okay.
A lot of students, yeah, quite a few students do that. So I know that that's not a problem.
Okay, thank you.
Okay. See you.